In this video, we will be discussing essential aspects of planting, growing, harvesting, and feeding alfalfa in Georgia. Alfalfa can be grown throughout Georgia depending on the variety selected. The development of varieties that are adapted to the challenging conditions in the Southeast has provided an opportunity for alfalfa production to increase again throughout the region. Let's start with a brief overview of alfalfa in Georgia. Alfalfa is a cool season perennial legume that is used in hay, baleage, silage, and grazing systems. This bunch-type legume has a more upright growth habit than other common perennial legumes. The anticipated production or yield of alfalfa is 5,000 to 12,000 pounds of dry matter per acre. Its nutritive value varies based on management. However, the anticipated energy or total digestible nutrients is 60 to 70%, and crude protein ranges from 15 to 25%. If managed appropriately, alfalfa will last for at least 3 to 5 years in the state of Georgia. There are several benefits to planting alfalfa. Alfalfa is the highest yielding perennial legume option in Georgia. Alfalfa can biologically fix nitrogen under appropriate soil conditions and if the associated bacteria are present. The taproot of alfalfa allows it to better tolerate mild to moderate drought conditions compared to species with more fibrous root structures. Alfalfa produces excellent forage nutritive value for all classes of livestock. Unfortunately, alfalfa has several challenges that producers should consider before planting. Alfalfa has a higher micronutrient fertility requirement compared to perennial grass systems, especially for hayfields. Alfalfa does not tolerate poorly drained soils or severe drought conditions. There are limited options for broadleaf weed control. There is also an increased incidence of disease and insect infestations compared to our perennial grass systems. Finally, it may be difficult to find alfalfa seed with the correct fall dormancy rating for your specific region. Now let's discuss the establishment of alfalfa. This video is only focusing on establishing alfalfa in a monoculture. Other resources are available in the video description below for how to establish alfalfa into Bermuda grass. Alfalfa variety selection should be based on the recommended dormancy rating for your region and the state. Varieties with a dormancy rating of 1 to 3 are not recommended for use in Georgia because they have no or little fall and late winter growth. Alfalfa varieties with a 4 to 6 dormancy rating are recommended for the mountains and Piedmont. These varieties are moderately winter hardy and have moderate fall and late winter growth. The coastal plains region requires a dormancy rating of 6 to 8, which are not winter hardy and are non-dormant if the rating is 7 or above. These varieties provide good fall and late winter growth. Examples of these varieties include Bulldog 505 and Bulldog 805. Both varieties were released in 2005 by Dr. Joe Boughton at the University of Georgia. Bulldog 505 is a semi-dormant variety and has a fall dormancy rating of 5. This variety is adapted to the Piedmont and mountain regions. Bulldog 805 is a semi-non-dormant variety and has a fall dormancy rating of 8. This variety is adapted to the coastal plains region. Both varieties have a broad spectrum of pest resistance and are considered dual-use varieties with good grazing or hay tolerance. Roundup-ready varieties provide many of the same benefits as the Bulldog varieties, but also allow for the use of glyphosate for weed control. Since the availability of Roundup-ready varieties is constantly changing, please consult your county extension agent for assistance in choosing the right variety for your region and use goals. Alfalfa should be planted in the fall in Georgia when soil temperatures are between 65 and 80 degrees Fahrenheit. It is not recommended to plant in the spring because of the weed competition. In the mountain region, alfalfa should be planted between September 1 and October 15th in most years. The Piedmont region often allows for plantings between September 15th and October 15th. Finally, alfalfa in the coastal plains should be planted between October 15th and November 30th in most years. The recommended planting rate for alfalfa in a monoculture is 18 to 25 pounds of pure live seed per acre. When grown alone, alfalfa should be planted on a 7-inch row spacing. All alfalfa should be planted 1/8 to 1/4 of an inch deep. Alfalfa can be planted into a stale, false, or well-prepared seedbed. No-till plantings are only recommended when interseeding into Bermuda grass. If you have questions about preparing your seedbed, please contact your local county extension agent. Now, let's talk about fertility at planting. Work with your local county extension agent to obtain a soil test at least 6 months prior to planting. Alfalfa should be tested at 0 to 6 inches for the topsoil sample and 6 to 12 inches for the subsoil sample. The topsoil pH must be at least 6.5 and the subsoil pH at least 5.5 before planting. Lime must be applied at least 6 to 12 months before planting according to soil test recommendations. Incorporate the lime into your soil during your field prep if possible. When establishing alfalfa, nitrogen may be needed to help the seedlings after they have emerged and promote rapid ground cover. During this time, apply 35 to 50 pounds of nitrogen per acre. Do not apply nitrogen at or before planting because this will increase the competition from annual grass weeds. Apply phosphorus and potassium according to soil test recommendations. Incorporate them into the soil if using a stale seedbed method. Alfalfa requires the addition of 2 key micronutrients for successful establishment. Most alfalfa seed now comes with the required boron and molybdenum in the seed coating. However, it is important to check the seed tag to ensure these nutrients are present in the coating. Most alfalfa seeds come pre-inoculated with the rhizobium inoculum, which is required for nodulation. It is good to check the seed tag prior to planting to ensure this inoculum is present. If not, apply the rhizobium inoculum. Inoculum adds about 30% by weight to the seed, so it is important to consider when calculating pure live seed. There are only 3 approved pre-emergent herbicides labeled for alfalfa at establishment at this time. These herbicides must be applied prior to planting and are only approved for use in alfalfa monocultures. After the successful establishment of alfalfa, it is important to control weeds during the post-emergent phase. These herbicides must only be applied when the alfalfa is at the correct height and has the minimum number of trifoliate leaves, which typically range from 2 to 4. Approved post-emergent herbicides for use in after alfalfa establishment may be found in the University of Georgia Pest Control Handbook. One of the most common questions that is asked for post-emergent weed control in alfalfa is, can I use glyphosate? This is dependent on the alfalfa variety that has been planted. Only use glyphosate on alfalfa varieties that have the Roundup Ready gene. If you do not have Roundup Ready alfalfa, mowing is often the best option for controlling problematic weeds during the establishment phase. The mowing height should be adjusted so little of the alfalfa is cut. You should plan to mow at least once per month, depending on the level of weed competition. Once established, alfalfa can suppress most weeds, and mowing may not be necessary if proper field management is followed. Let's move on to managing established alfalfa. We will start by discussing fertilization of established alfalfa. Soil fertility affects yield, carrying capacity, persistence, resistance to stress, nutritive value, and many other aspects of the forage production system. A balanced fertility program is critical to sustained longevity and economic sustainability of forage production systems. There are 16 essential nutrients for plant growth, and limiting their ability will negatively impact production. The three most common macronutrients we will apply in forage systems are nitrogen, phosphorus, and potassium. Nitrogen is important for the formation of plant proteins, an integral part of chlorophyll, and thus vegetative growth and dark green color. However, nitrogen is not required for alfalfa production if nodulation is occurring. This is because alfalfa has nitrogen fixation capabilities, resulting from the nitrogen-fixing bacteria that form root nodules on the alfalfa roots. To check the roots for nodules, carefully cut around an established alfalfa plant with a shovel before scooping from the ground. Rinse the roots gently with water to remove excess soil. Nodules that are fixing nitrogen will appear pink or red. Phosphorus plays a crucial role in many plant functions, including photosynthesis and nutrient movement within the plant, in addition to root development. Phosphorus is not often applied to our grass pastures, but may be required for alfalfa fields that do not have a history of grazing or manure applications. Phosphorus should be applied at up to 100 pounds of P2O5 per acre per year at any time over the course of the year. Potassium is crucial to many plant functions, including water uptake and movement in the plant, photosynthesis, and carbohydrate storage. This is a critical nutrient to maintain stand density and longevity, plant vigor, disease resistance, and winter survival. Potassium should be applied at up to 250 pounds of K2O per acre per year. Apply 1/3 at greenup, 1/3 at midsummer, and 1/3 in the early fall. The two most common micronutrients that we apply to alfalfa are boron and molybdenum. Boron is applied on an as-needed basis based on tissue sampling. Apply up to 3 pounds of boron per acre depending on the source in the late winter or early spring. Molybdenum is also applied on an as-needed basis based on tissue sampling results. Apply every other year in the late winter or early spring when the alfalfa is 6 to 8 inches tall. Let's shift gears and talk about the importance of soil testing and your soil pH. Since forage can only be as productive as the most limiting input, it is important to make fertilizer decisions based on reports from a soil test. Harvesting forage removes significantly more nutrients from the soil than grazing, so these acres must be sampled more frequently. Therefore, we recommend collecting soil samples on hayfields annually, while pastures only need to be sampled every 3 years. Soil pH affects many soil properties, including nutrient availability, soil structure, soil biological activity, and potential for aluminum toxicity. As the soil becomes more acidic, important macronutrients become more limiting to the plant and are not taken up as efficiently. Here is a list of the most common sources of fertilizer used for forage production across Georgia. As you can see, the fertilizer source can impact your soil's pH. Although this does not necessarily make one source better than another, it may impact the frequency in which you need to apply lime to your farm. If you encounter a fertilizer source not on the list below, consult your county extension agent on its potential use in your system before purchasing the material. Both dolomitic and calcitic or high cal lime are recommended for use in Georgia. Many local fertilizer distributors will call these ag limes, so you may need to clarify which product you are purchasing. Dolomitic lime contains both calcium and magnesium, whereas calcitic lime only contains calcium. There are many alternative lime products available. These may include products such as wood ash, eggshells, and more. Like animal manures, these products are highly variable and should be tested for their liming ability before application. Other macro and micronutrients are rarely limiting in alfalfa pastures or hayfields, so applications are made on a case-by-case basis. If a nutrient deficiency is suspected, please contact your local county extension agent for assistance with plant tissue testing. Forage systems are incredibly complex, so it's not surprising that many producer concerns are related to weed management. There are 4 weed control strategies that we can employ in alfalfa production systems. In many cases, you will use a combination of these strategies to control the weeds on your farm. This combination of control options is often called integrated weed management. Cultural weed control includes any management practice that improves the condition of alfalfa. This includes proper grazing or harvest management and applying lime and fertilizer according to soil test results. The best way to prevent weeds is to keep the ground covered. A healthy and dense sod will limit the opportunities for weeds to invade. Mechanical weed control includes weed removal techniques with a machine or implement. We are limited to mowing in established alfalfa stands, but tillage can be used strategically during renovation. Biological weed control often includes using natural enemies of pests. However, this may also include using the weed's growth habit and life cycle to our advantage. For example, some weeds are more susceptible to chemical weed control during certain seasons than others. This can improve the efficacy of the herbicide application. Chemical weed control includes any application of an herbicide to the forage system. Herbicides that are applied to prevent weed germination are called pre-emergent herbicides or PREs. Herbicides that are applied to control an emerged weed are known as post-emergent herbicides or POST. Refer to the specific product label for instructions on application type, rate, and timing. Please refer to the most recent edition of the University of Georgia Pest Control Handbook for updated efficacy ratings. This resource is available online and is free to download. The link is in the video description below. If you need help selecting an herbicide, please contact your local county extension agent. The effectiveness of a control strategy depends on proper identification of the weed species, stage of growth, plant stress, precipitation, temperature, time of year, application method and rate, and the ability to follow all instructions from the herbicide label. Insect control is another critical topic for maintaining established alfalfa stands in Georgia. Scouting for above-ground insects is most common with a sweep net made with a wood or metal handle and a cloth net. Walk randomly across the field and swing the net down deep into the canopy. After 20 to 25 swings of the net, carefully inspect the sample to see which insects are present. Use a large freezer bag or insect cube to contain the insects while you identify them. If identification is still a challenge, freeze the insects for 10 to 15 minutes and then place them on a solid working surface. Scouting for the alfalfa weevils population can be done using the shake bucket method. Walk the field and randomly stop every 20 to 30 steps throughout at 6 random locations. Measure the height of the alfalfa plants. At each of these locations, collect 5 stems. Be sure to gently break the stem off at the crown of the plant to not lose any larvae in the process. Once 30 stems have been collected, firmly grasp the stem in the bucket and shake vigorously to dislodge the larvae. Next, count the number of larvae present in the bucket. Record this number and divide by the total number of stems collected to get an average. This number, along with the height of the alfalfa plant, will help determine the treatment level for the field. Thresholds for chemical control methods are provided in the Georgia Pest Control Handbook. Scouting for below-ground pests usually requires digging several shovelfuls of soil to scout for pests. The only exception is mole crickets, as they are too evasive to be found reliably with a shovel. You can use a soapy water mix with a 1/2 ounce dish soap per gallon of water to flush out mole crickets, but other below-ground pests will not come to the surface. All insecticide recommendations may be found in the Georgia Pest Management Handbook. Viruses, bacteria, fungi, and nematodes can occasionally cause significant problems in alfalfa. Each of these infestations must be confirmed by a pathologist or similar scientist. Contact your local county extension agent if you suspect an issue in your alfalfa. Well-managed alfalfa pastures and hayfields are generally free from most disease problems. There are no cost-effective or labeled pesticides to control the above list of pests in alfalfa. If a disease outbreak occurs in alfalfa, the best option is to harvest or clean off the affected material as soon as possible. Prevention is critical for protecting alfalfa stands against disease. Apply potash as soon as possible. Nearly every diseased stand of alfalfa has a low soil potassium level. It may take several weeks to see the effects of potassium, especially if the alfalfa is really stressed. Adjust your soil pH if needed. Potassium will become less available to the plant when the soil pH is outside of the neutral zone. If the pH is low, the plant cannot take full advantage of the potash that is being applied. Maintain a frequent harvest or grazing interval. Actively growing forages should be grazed or harvested approximately every 28 to 35 days to optimize forage yield and quality. Frequent removal of the forage mass will also prevent forage diseases. Potassium moves from older to younger leaves as the plant grows, which leaves the older leaves more susceptible to disease. Avoid over-irrigation if applicable. Diseases thrive in warm and wet environments. Although we cannot control the weather, we can adjust irrigation. Irrigation is only needed to supplement approximately 75% of evapotranspiration for economical forage production. Good grazing and harvest management are important for preventing many of the challenges we have discussed in this video. Let's start by talking about managing alfalfa for grazing. The anticipated production season for alfalfa is April to November each year, depending on the freeze dates in your region. If planning to graze alfalfa, you should begin when alfalfa is at least 10 to 12 inches tall and end when alfalfa is 4 inches. It is recommended that you rotationally graze the alfalfa because it cannot tolerate continuous grazing. Rotational grazing is the practice of moving a group of livestock between two or more pastures. Pastures may be divided with permanent or temporary fencing. Actively growing alfalfa can be rotationally grazed every 28 to 35 days following green-up in the spring. It is important not to graze the alfalfa until it has reached the 10% bloom. Two of the most common challenges for grazing alfalfa include managing for forage quality and preventing bloat. The forage quality of alfalfa will vary throughout the grazing season, depending on both weather and management. Bloat may be of concern when the ruminant animals graze straight alfalfa or the pastures have greater than 40% alfalfa. Never allow hungry animals to graze this material, as it will increase the chance of bloat occurring. Bloat typically occurs when ruminant animals have not had access to feed for more than 12 hours and then consume a large amount of alfalfa. It is important to feed a feed supplement containing anti-bloating characteristics such as an ionophore or a chemical bloat preventative such as poloxamine to reduce this risk. Good grazing management is extremely important for alfalfa longevity. Always ensure there is adequate residual forage or stubble left after the animal has grazed. This material is needed for photosynthesis after defoliation. Proper rest is critical to stand longevity. This is important for in-between grazing events so the plant can restore root carbohydrate levels that may have been depleted when regrowing. Monitoring forage availability is important in making grazing decisions. A grazing stick or ruler is the most cost-effective way to measure forage yield, which can then be used to calculate forage availability and length of grazing. This factor is also important in making our stocking decisions. Finally, it is important to know when to stop grazing. There may be periods of drought that can limit forage growth, or excessive rainfall that may restrict access to certain areas of the farm. In these instances, a sacrifice lot may be needed to prevent overgrazing and provide an area that the animals may be supplemented with hay and grain until the situation improves. If you need help with grazing calculations and predicting forage availability, an example grazing workbook is available for download on our website. This Excel file can serve as a template for predicting and monitoring forage on your own farm. Let's shift gears to discuss harvesting alfalfa as a stored forage. The anticipated production season for alfalfa is April to November each year, depending on the freeze dates in your region. Alfalfa should be harvested to 2 to 4 inches tall, depending on your operations objectives. There are some potential challenges with harvesting alfalfa. First, forage quality declines rapidly with maturity, so actively growing alfalfa should be cut approximately every 28 to 35 days to optimize nutrition and tonnage. Second, alfalfa has a woody stem that may require more time to cure or dry than fine stem grasses. Finally, hay and baleage harvesting equipment is expensive, and the cost of owning equipment may not be justified for operations smaller than 100 acres or with fewer than 100 head of cattle. Harvested forages can be an important tool in grazing systems. Surplus forage can be harvested following periods of excess forage growth when forage availability exceeds forage demand. Storing these forages for later use allows producers to better protect the quality of the forage product and minimize waste in their production system. Forages can be harvested or conserved as both hay and baleage. Hay is defined as forage stored in square or round bales at less than 20% moisture. Baleage or baled silage is defined as forage stored in a round bale between 40 and 60% moisture, then wrapped in plastic to ensure anaerobic fermentation. Now let's talk about producing high-quality hay. Ideally, a hay mower with a roller or crimper type conditioner will be used to cut the alfalfa to the recommended stubble height. A mower without a conditioner can also be used, however the drying time will be slower. Mowers with an impaler or tine type conditioner are generally not recommended for use in alfalfa systems because the conditioner is not as effective and may damage the leaves. A tedder may be used to speed the drying process. Tedding this material may cause significant leaf loss, though, if the implement is not properly adjusted or used on forage without a dew or below 50% moisture. A hay rake must be used to merge the swath rows into windrows after the alfalfa is allowed to wilt to the desired moisture. There are several types of hay rakes available. Rotary rakes are preferred because they are less destructive than a V or speed rake and parallel bar rakes. Rotary rakes are powered by the tractor's PTO, not ground-driven, as is often the case of the other two. This allows the forage to be gently swept into a windrow with the rotary baskets rather than being pushed or pulled across the ground. This can help you retain more leaves and reduce ash or soil content of the harvested material. If speed or parallel bar rakes must be used, adjust the tines so that they minimize contact with the ground. Hay can be baled with a square or round baler. Balers are used to accumulate the forage to be stored in the final product. There are many types of balers available on the market, each with their own pros and cons. Regardless of the baler used, it is important to make dense and uniform bales to improve nutrient retention during storage. The steps for producing high-quality baleage are similar to those for hay. The differences arise in baling and handling after baling. Baleage is typically baled in a round baler, and the baler needs to be designed to accommodate these heavier bales. Bales should be wrapped within 4 hours of baling to ensure appropriate fermentation occurs, but no more than 12 hours. There are 3 types of baler wrappers available. An individual bale wrapper allows for single bales to be wrapped. Typically, a well-trained operator can only wrap around 20 bales per hour, but these bales allow for easier feeding. An inline wrapper allows for bales to be wrapped in plastic within a row. Operators can wrap at least 40 bales an hour, but once the tube of baleage is opened, it must be fed at a rate of approximately 1 bale per day. An integrated baler wrapper simultaneously bales and wraps the bales in plastic. This is the most expensive option, however, it requires less labor than the other two. Since the bales are wrapped immediately, baleage must be moved using a bale squeeze to prevent puncturing the plastic. Finally, let's discuss forage testing. Each lot of forage should be tested separately. A lot is defined as forage that was managed the same and harvested at the same time, out of the same field and under the same conditions. Ideally, forage should be tested after baling or purchase and again before feeding if the difference between the 2 time periods is greater than 4 to 8 weeks and the forage is stored outside to account for storage losses. Use a hay coring probe to randomly collect 15 to 20 cores from each lot. Insert the hay probe on the side of the bale, coring towards the center so you cross several windrows. Remove the hay probe and empty the contents into a clean container. After collecting the cores, mix the material thoroughly to decrease bias. Pour in enough sample to fill up a 1-quart plastic bag. If you are sampling baleage, use baleage tape to put an X of tape over the hole to prevent air from entering the bale. Thank you for joining us today. If you have not yet downloaded the book, the Alfalfa Forage Production Guide is available for free download from Apple Books and other platforms. The links may be found in the video's description below. If you need more information on alfalfa forage systems, please contact your local county extension agent. If you need help finding your nearest agent in Georgia, please call 1-800-ASK-UGA-1.